afternoon, my name is Alejandra and I'm a senior pre-med studying biochemistry and molecular biology here at Chapman University. The title of my presentation today is the new warning lights of pancreatic cancer. Some of you in the audience have been impacted by pancreatic cancer, either as a patient, a caregiver, a family member, or someone really close to you was diagnosed with this disease. I personally lost my aunt to pancreatic cancer 6 years ago. Since the day my aunt was diagnosed with this disease, I became very curious about cancer, and I started researching more. And I even decided to try and pursue a medical career in the future to help cancer patients. I'm happy to be here with you today to share some information about a recent study that could potentially change the way pancreatic cancer is detected and diagnosed. Now, you may ask why pancreatic cancer is so hard to diagnose. Well, the pancreas is a small organ that is found behind the stomach, and this location makes it really hard for physicians to look at the condition of this organ during regular checkups. In addition to that, during the early stages of this pancreatic cancer, we rarely see any symptoms. And if we see symptoms for this disease, it's usually attributed to other disease when you go to the doctor. Then the patients have to wait until they go through surgical procedures to when the doctors finally realize how bad is the situation, and usually at that time it might be even at stage 4, which is also known as metastasis, which is when the cancer cell has spread and move on from the original tumor site to affect other organs. Then the patient has to wait until they have fully recovered from their surgery before attempting any other type of treatment. The study that I will focus on today talks about circulating tumor cells, which are known as CTCs. Researchers at UCLA proposed that these cells are found floating around in the patient's blood. This is why they are known as biomarkers. Well, a biomarker is an indicator that can be measured in the body to tell us something about the patient's health. We can picture these biomarkers just like the warning lights in a car, because we all know when these lights come on, there is something wrong with the car and we should take it in for a checkup. So when these biomarkers show up on a blood test, the physician will note that there might be a chance that pancreatic cancer is present in the patient. For this specific study, the researchers decided to take a group of patients that were recently diagnosed with pancreatic cancer. In addition to that, they must have not gotten any kind of treatment or surgery after the diagnosis. Also, for this specific study, there was an additional group of patients that were not diagnosed with pancreatic cancer, and it was expected that no CTCs were going to be found in the blood of samples of this patient. Now, before I start telling you more about how the experiment was carried out, I want you all to picture everything that I'm going to say as if we are making oranges. I know this sounds really, really funny, but please bear with me. For the start of this study, what it was asked from the patients was to take a small blood sample. The researchers then took this blood, and we know that in the blood we found these red blood cells, which are the small circular red blood cells that we can picture as the oranges in this case. Then the researchers took these cells and squeezed them to try to make all the content that was inside of them to go out and form a liquid solution, which in this case will be our juice. Then this juice will be loaded into a small chip that in this case is called the nano-Velcro CTC chip, which already sounds like one of those very fun, fancy names for kitchen equipment that we sometimes see at the store. Well, this small chip was then washed with a solution that has colorful small molecules that will attach to our CTC cells. We can picture these small molecules just like when we add sugar to our orange juice, because we know that this sugar will attach to the orange juice molecules just like these colorful molecules in this case will attach to the CTCs. Once everything is loaded on the chip, the researchers took this chip and placed it under a microscope. Then they started looking to find any color spot that will be present in the chip and the blood sample, and that's how they started to count how many CTCs were present in the blood of these patients. When looking at the results of this experiment, the researchers focused on two things, which was the sensitivity of this test, which means how good was this test in detecting if the blood samples correspond to patients that were diagnosed with pancreatic cancer. They also focus on the specificity of this test, which is how good is this test in detecting if the sample corresponds to a patient that was not previously diagnosed with pancreatic cancer. After the final count of CTCs, the test ended up being highly sensitive, meaning that all the blood samples that were taken from patients that were previously diagnosed with pancreatic cancer, in fact, had amounts of CTCs. And it was also discovered that as the cancer stage increased, the count of CTCs also increased. And it was stage 4, known as metastasis, the one that had the largest amount of CTCs present in the blood. The test also had a high specificity, meaning that from that group of patients that didn't have a previous pancreatic cancer diagnosis, they didn't found any CTCs present in the blood cell. So with this result in mind, we can see that it will help improve the way pancreatic cancer is diagnosed in the future. Because with a small blood sample, the patient could get an efficient and efficacious diagnosis of pancreatic cancer without having to go through really hard tests or exploratory surgeries. Even though more research is still needed, it's a great start into helping improve the way this disease is diagnosed. Now, I know I told you a lot of information right now, but there are 3 main takeaways that I want you to get from this talk. The number 1 is that CTCs can and will hopefully help improve the way pancreatic cancer is diagnosed. Second is that this technique will provide the patients with new alternatives to treat this disease before having to go for a surgical procedure. And lastly, I want you all to remember that you are not in this fight alone, that we are all here together to fight against cancer with you. And even though it's taking a while, we need to remain hopeful because medical advances are being made every single day. And for now, we have each other to keep helping in this fight. If you have any questions about CTCs or pancreatic cancer in general, feel free to contact me or talk to me after the presentations are done. If not, my email is right here, solis121@mail.chapman.edu, and I will be happy to answer any of your questions. Thank you.